Hi everyone, in this video we are going to discuss about OSPF operation and database. OSPF stands for Open Shortest Path First. So OSPF is a routing protocol and the job of every routing protocol is to learn routes, add them in the routing table and make routing decision. So at the end of routing protocol, every router will have some table like this. In this table they will have routes from that particular route to different destinations. So for that, every routing protocol uses some kind of routing algorithm, and routing algorithm is simply a logic or maybe a mathematics which is used by the routers to learn and choose best path. So for path to different networks, router may have many available paths and it has to select one of them which will be the best for that from source to destination. So that is the job of routing algorithm. And and the routing algorithm can be classified as so they have what kind of algorithm they can use, these routing algorithm. So they can use distance vector algorithm or maybe link state algorithm or maybe advanced distance vector. OSPF particularly uses link state routing protocol that's based on Dijkstra's algorithm. And link state is basically the information about a link. And now what is link? So link can be an interface, for example, on this router. So physically this will look like this. On this router, we will have interfaces. So that link state information can be information about a link, that can be an interface, or that can be a network segment, or that can be a stub network. For example, Ethernet, where we have only one router connecting all Ethernet computers and the rest of the world. So that's a link, and the link state information, it can have the network prefix, prefix length and cost. So it will have information about network prefix, prefix length and the cost. And the OSPF enable routers exchange this information using 5 types of packets. So now they have to, like in our network we can have many routers and they need to exchange this link state information with each other, and this exchange of information takes place with the help of 5 types of packets. And these 5 types of packets are hello packet, database description packet, link state request LSR, and link state update LSU, and link state acknowledgement packet as type 5. So I have written these types of as well, types of those messages or packets. And after that, we are going to discuss these steps which are taken by by the OSPF routing protocol. Very first step is to establish neighbor adjacencies. We'll discuss in details in next slides. Second step is exchange link state advertisements. Third step is to build a link state database. And then fourth step is to execute the shortest path first algorithm. Fifth step would be to choose the best route. So in the very first step, what happens? So in the very first step, as we enable some routing protocol, OSPF routing protocol on some of the interfaces of the router, they start sending hello packets with each other. And as a result of this exchange of hello packets, these routers actually establish a neighbor adjacency. So they send a hello message. For example, this router will be sending hello to this router and this router will be sending hello to this routers. In this way, they establish neighbor adjacency. And the adjacency means the routers, they establish a neighbor relationship with each other. And as a result, they create Adjacency database, and which creates a neighbor table. So once they have exchanged these hello packets, they establish neighbor adjacencies, and this creates a neighbor table. And on Cisco router or switches, if you want to see, for example, that, and by the way, this neighbor table will have a list of all neighbor routers. For example, if you focus on this router will have a list of all routers which are its neighbor. Maybe if you have one router here, maybe one router here. So this router will have information about all neighbor routers. And yes, if you want to see this on maybe Cisco devices, so we can use this command, that is show OSPF, show IP OSPF neighbor, and it will give a list of all the routers which are neighbor of a particular router where we are using this command. Now, once they have established that neighbor relationship with each other, they start sending link state or exchanging link state advertisement, LSAs. And this LSA has information about the link state and cost of each directly connected link on that particular router. So every router will be sending link state advertisement to every other router. So they all exchange link state advertisement until all the routers in the network or in the area have all LSA. It means this will be sending to this will be sending to this will be sending to this. So all of them, they will be exchanging this LSA. And at one stage, all of these routers, they will have all link state advertisements or LSA. And these LSAs, the combination of all these LSAs from all these routers actually builds a database that is known as link state database. Link state database. And as a result of this link state database, or based on these link state advertisements, these routers build a topology table. And in that topology table, they will have the list of all other routers in the network. So for example, on every router, they will have their own topology table. And this topology table will have information about all other routers in that particular area. And this topology table will be identical in all these routers which are in a single area, in the same area. I have discussed these areas in some other videos. And if you want to check, for example, this database, which is a LSDB, link state database, we can simply use this command on that particular router, that is show IP OSPF database, and it will give you information about all these routers which are in that area. And this is actually topology table, and associated database is called LSDB. And the fourth step will be to execute the OSPF algorithm. So once we have link state database, they run an algorithm, that is Dijkstra's algorithm, OSPF algorithm, and this algorithm actually creates a shortest path first tree. So in this tree, there will be a root node, and then there will be branches like this. So they create this shortest path first tree like this. And on this shortest path first tree, once they have created, they will be creating, or they'll be choosing the best path. And so based on this shortest path first tree, best path to reach to each network is selected. So for example, every router, they will be running this algorithm on that shortest path first tree. Every router individually, they'll be calculating it, and they will be selecting best path to every other node network. For example, on this network, if we focus on this router will have a best path to reach maybe this network, to this network, and to maybe this network. In the same way, let's say this router in that area, this will also be running this algorithm on that shortest path first tree, and it will be selecting best path to reach every other network in that particular area, and they will enter these entries in the routing table. And this creates a forwarding database which actually creates the routing table. And this routing table, important thing is that this routing table will be unique for all routers in the network. So this routing table will be unique for this router, this will be unique for this router, this will be unique for this router. So every router will have its own routing table. It will be unique. And if you want to see that route, the routing table, then we can run this command show IP route. So we can have many routers in an area, and if you want to see any specific routing table, like on any specific router, then we can use this command, that is show IP route, and the routing table on that specific router will be shown to us. For example, here this O shows that this is the route which is learned using OSPF routing table. So I think that's it. I wanted to just go through some of the messages and the OSPF operation and some database. Of course, this is not in details, but I have somehow shown you briefly the operation of OSPF and its database. I hope this might maybe useful for some of you, and thank you very much for your time. Hope to see you in some